Can some of you hear me?
Yeah.
Okay, all right. I'm sorry, this Zoom has been awful this morning. Okay, finally, I can see you guys. Took 11 minutes for Zoom to admit you into this. Okay, can you, all right, so I'm glad this happened because I was about to restart my computer. It's not good. All right, so I think, is everyone's in this session, right? So can you just say, you know, I'm here or something, just so I can hear a few voices?
Here.
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 All right, excellent.
Here.
That's
Here.
Here.
All right. Great, Jet, great. All right, welcome to, so I was gonna send you an email there, but that's not necessary. All right, welcome to ITS 140 online edition. So yeah, you know, so I used Zoom last semester and had no problems with it. This is actually the first time, because it's usually pretty quick to allow people in. So I'm not sure, but hopefully it, you know, they're gonna fix that problem. All right, so anyway, so you know, welcome to ITS 140. So this is a course on programming, basically. So it's your introductory course to programming, actually. So today, what I'm going to do is I'm going to just go over all the details of the course. I will just take a lot of time on that. And then towards the end of the course, I will basically start the lecture, if you will, and start getting into the concepts, okay? So please stop me if at any time something is confusing or if you have a question. All right, so the first thing I'm going to do is I'm going to share my screen, and I'm going to go to our program for materials. So can you guys see Brightspace?
Yeah.
Yes.
Okay, great. All right, so this is basically Brightspace. You know, you're probably familiar with it. So our course is ITS 140. You might see on your Brightspace that there's actually two sections, 140.009 and 140.010. One is for the lecture and one is for the lab. I basically will just use one. So this one, you know, I won't post any materials here. Instead, everything is just going to be posted on 009. So if you click on it, you know, you'll find information on the website. You know, don't worry if, you know, things are confusing. Believe me, Brightspace is new to us as well, and we're a little bit confused by it. Okay, so don't worry about it. I'm going to try to keep things simple. I know it's very busy and it has a lot of things, but really there's going to be just a few things that you have to worry about. There's going to be announcements, and usually the announcements are here, so you can see my announcements. I posted them here. I'll talk about each one of them. And then everything related to content, will be here. Okay, so if I click on content here, you'll see that these are all the materials, okay? So usually what I do is I just click on table of contents, and then I have this list, you know, that goes down here, right? And then in each one of these, let's call it a module, I have materials. So for instance, in the admin, I have the syllabus and relevant links. And then there's going to be like instructions on how to do the Zoom. So you just click on that. It's a little text file. And then after that, we'll get into the topics, okay? The topics of the course, you know, intro to programming, inputs, processing outputs, modules, decision structures, and so on. Okay, so that's just a little bit about, you know, Brightspace. And then whenever I have lectures and labs, for instance, if this is, you know, the first week, you know, you'll find here I have some slides. I will also post, you know, lab materials. The Dropbox for you, the link for the Dropbox for you to submit your assignment will be here. You know, if we're doing any coding and I we've been doing a Jupyter notebook or something like that, that will also be here. Okay, so all materials basically will be here. I will also provide a link to my GitHub, and on my GitHub I may have code examples basically that you can reference for some of the homework assignments, etc. All right, so that's Brightspace. Are there any questions about Brightspace? Okay. Seems like there's no questions. So I'll give it a few more minutes to get, to make sure everyone comes in. And then after that, we will, I need to do, just take a few minutes to do kind of a roll call because for the first 2 weeks, I have to take kind of a roll. It's something that I have to enter in the system just to indicate who's here. Okay, so I'll wait a few minutes for that. Let's grab that. All right, and so now, so Brightspace is the main source of materials. However, additionally, I may have other resources. So, so I will talk about, I guess I haven't added the link here yet, what I did, but I'm gonna add another link. Oh, here it is. No, I did add it. It's under admin. So if you go under admin and you click on course website, I have a separate, just over the internet, kind of a backup in case Brightspace goes down or something. I also have a website that you can just follow that link. And on there, I basically have a description of the course and I will have relevant links. Now, I should say at this point that I am, we're doing the course synchronous, which basically means that it's a live lecture discussion, but it is virtual, in virtual space. However, I'm also recording the videos, okay? So I'm also recording videos. So what's gonna happen is, after every discussion, after every lecture or lab, I'm gonna save the video and I'm gonna post it on YouTube, okay? That's probably, it's just the most stable platform to have your videos, and then I'm going to link them on this website. The reason why I wanna link them on this website is I have a nice calendar here of the semester, and so that way you'll be able to keep track of what lectures and labs we did on what dates. Okay, so the calendar here. So, so just a few pieces of information. So this course, will cover fundamental concepts related to programming using the Python language. How many of you have ever used Python before?
I have.
You have one? Anyone else?
I haven't, but I'm familiar with the C library.
All right.
So I get the concepts of Python.
Oh, programming. Right, exactly.
Yeah.
Good. Who else? Anyone else? All right, that's fine. That's great because this is an introductory class. So, the assumption is that even if you've never seen programming before, you'd be fine. And so that's great. So the course, Python is one of my favorite programming languages. We will talk about a lot of things this semester related to the Python language and everything that we can do with it. I mean, sometimes I have to pause to read the chat. Give me a sec. Okay. All right. And some of you have not. And as I said, that's perfectly fine. You will learn certainly a lot. So the course actually has two objectives. One is to just kind of teach programming. All right. So the idea there is that you're learning programming independent of the language. However, the language influences the things that you have to learn about programming quite a bit. Now, as it turns out, all programming languages basically have the same ideas and the same concepts, same topics. Okay? And so once you learn how to program in one specific language, you can basically apply those same principles to other languages. So that's one of the great advantages. However, we believe, that we want to tie this to a language that you can actually use in your, later on. And so Python is really one of the more popular languages right now. It's very powerful, and you can use it for a lot of things. And so, we will do a lot of examples, certainly, on the Python language. Okay, so so as I said, then the course will cover fundamental concepts, but all of it tied to Python. The topics will include, the Python language, just a description of it, and then we'll look at variables, modules, algorithms, logic, conditional structures, iterative structures, lists, which is data structures in Python, and files, and various other things as well. So it's a very introductory course. Python has a lot of advanced concepts, but that we may not get to. And in particular, Python has a lot of libraries that are very powerful. Okay, so I may just give you just kind of a taste of what all those libraries are for. Certainly, as you progress through the program, you will start seeing these libraries apply to things like networking, applied to data science, applied to various different areas. Okay. All right, so just a few other things. So the time and place, we will meet Tuesdays and Thursdays from 12 to 2 p.m., or I should say from 12 to 1:40 p.m. On Zoom, and the Zoom information is on your website. I'll talk about the textbook in a second when we read through the syllabus. I'm Professor Calix. Okay, so I'll be your instructor for this this semester. When we're back on campus, my office is Anderson 241, but obviously currently we are doing everything online. Online office hours, I need to change this actually. Online office hours for this course are gonna be Monday. I think I have this updated on the syllabus. I need to change it here. Mondays from 12 to 2 p.m. or by appointment, which basically means you send me an email and then we'll schedule something that fits your schedule and my schedule. Here's just a few links to PNW if you're new to this area, to the campus. It's got some information on restaurants, the map, etc. Once you're on campus, that should be useful. I talked about GitHub. So if you've never heard of GitHub, GitHub is a place online where you can have an account and then on there have all of your code. So you have a lot of code and you have code examples and you have descriptions of the code there as well. So I like to use GitHub basically to just make my code available, and that way everyone in the class has access to it. Are there any questions so far? Okay, no questions so far. Now let's keep going. So I talked about the video. So like I said, we're doing the sessions live. And feel free to say, to speak. Okay, you don't just have to write on the chat. It's actually a little bit easier for me if you just ask questions. So the videos, I have a YouTube channel that I've created to put all the videos of courses. So be aware that we're recording the videos and I will be posting them usually within 1 or 2 days on this channel. So you can subscribe to the channel, I guess. But usually, like I said, I like to just put the independent links here. That way you will know if for whatever reason you miss class on September 1st, you can just go in, oh, September 1st, here's the video, and you can see everything that we did. Okay? All right. As I said, Brightspace is the place where you will submit your homework assignments. So no homework yet, but as we start getting started with that process, and like I said, I know you guys are new, you're freshmen, so certainly I will take my time and give you time to get used to the way we do things. All right. I'm sure you have a lot of questions about this, right? Lab environment. So I'm assuming most of you are Windows users. Are there any Linux or Mac users in the audience? So no one, but you are Windows users, correct?
Yeah.
Mm-hmm. All right, good. So yeah, so usually, as you progress through this program, you will see that we use Linux a lot in the course. However, for this class at a freshman level, I can't expect you guys to have familiarity with terminal and Linux, so we won't really use Linux. However, for those of you that like to use Linux, you can always just get VMware from the university, download this VM, and you can always try the code in the Linux environment. For those of you that are daring and are willing to spend a little bit of your own money, you can also always go to the cloud, AWS, right? And you can rent instances there and basically get, do the work on the machines in the cloud. So that's also a possibility. For our class, I believe we will mainly focus on this, okay? So usually Python is a very simple language. You can actually just install a very simple Python program, the editor, and then you can write your code there. And that's fine. If you want to do that, that's perfectly fine, okay? What I will suggest you do, just so that you get more out of it, is that you install a program called Anaconda. So if you notice here, I have provided a link. So this will be really your first homework assignment, okay? So your first homework assignment, which I'm not gonna grade and you don't have to submit, but it's just something that you have to do, is to get started with your, with the lab environment, right? So if you have, so imagine you have a Windows machine, your Windows machine at home, and then you need to have, I believe, Anaconda needs somewhere between 3 gigabytes and 4 gigabytes of storage space. So, and it will have a lot of programs that you don't need for this class. So don't get overwhelmed. However, it's a really nice platform with a lot of things in it. And so that, that's why I kind of want you to consider using this. Otherwise, feel free to find any Python editor that you wanna use and use that one. Okay, a Python editor, if you don't know what it is, it's just a program where you write code and see it execute. I will actually, instead of using a Python editor all the time, you will see me use something called a Jupyter notebook. Okay, so I will be using Jupyter notebooks in Anaconda. And there are various ways of using them. I will just show you some basics of it. But the great thing about Jupyter notebooks is that I can put code, but I can also write like descriptions of things. So that way, you can say, oh, here's the code, but you can also explain it. You can put links to images, write equations and lots of things. So it's a very versatile approach. Okay, it's kind of web-based, which is interesting, and so we'll play with that concept. And at the end of the day, you can actually even print it as a book. So maybe, if you're diligent in your notes, and this is what I want you to understand. Some of you might like to take notes, okay? And if you're taking notes, take the notes in your own Jupyter notebook. And the best way to describe it is that at the end of the semester, it's like you've written a book, but it's an electronic book. And by the way, the code that you have in that book, you can just hit run and it'll run. And so you can modify it, you know, you can do a lot of things. So I recommend as a student, especially if you're the kind of student that likes writing on a notebook, you know, taking your own notes. I've seen students do that a lot. You can do it with a Jupyter notebook, and whenever you have code, you can actually run the code. Are there any questions about that?
Yes. So the Jupyter Notebook, will that be taking place of inline comments, or will we still be doing those for our code?
So that's a good question, actually. So inline comments you would do if you're just writing code, let's say, and you put the comment in there and you want to say this piece of code is for this. So if you have that approach, you can do it. You can do that. In the Jupyter Notebook, you don't have to, because the Jupyter, and I'll show you guys, the Jupyter Notebook is almost like a book, but it just so happens that where you have the code is executable. You see that? And it's really a web page. So the idea is really to learn the concepts of programming. And then, yes, later on, if you were developing an actual application, then you probably won't use a Jupyter Notebook, if that makes sense.
Yeah.
So if you're developing,
because I never heard of it bufore. So
yeah, no, it's fine. It's just, you know, they're very popular. I do want you to stress that they're not experimental or everything. They're actually literally used, you know, all over the world, and very popular.
Yeah, that's really cool.
Appreciated, because as I said, especially I've seen students that do this a lot. They just start typing everything I'm saying. They're typing it on a Word document or something. Might as well type it on a Jupyter Notebook, because the code is there. It'll run. This being a programming class, it makes sense. But
And
question, actually. Yeah, go ahead.
I have one more thing as well. For the VM, the Ubuntu VM, the download link, at least for me, I don't know if anybody else in the class has tried downloading it. It gets to about 80%, and then I get a network error, and it doesn't finish.
So this one's 1604. Okay. I will have to look at that. Okay.
Yeah, I tried it just last night. So.
Oh, okay. I will take a look at it. As I said, that's only really already know Linux, because I will not be able to provide Linux support this semester for this class. So if you already know Linux and you just want to, like you just said, right? So if you want to do things like you're doing applications and you kind of want to put your comments in the source code, you know, do it in Linux, right? But otherwise, if you have a Windows machine, you know, usually in a class like this, the majority of students are familiar with Windows, not so much with other operating systems. So the preferred method will be on Windows with something like Anaconda, for instance, and the Jupyter Notebook, or just regular code, right? So just regular editor is also fine. Make sense? All right, so let's continue. So I'm going to go ahead now. So I talked about the Jupyter Notebook. I'm going to click on the link for Anaconda, right? So I click on this link, and as you can see, it takes me to this website called Anaconda. Basically here you have your data science toolkit. So Anaconda has been developed for data science. So we in our program actually have a minor called Applied Science, where we cover a lot of courses in data science. So certainly 140 kind of gets you going in that direction, because the main language in that minor is Python as well. So anyway, so this toolkit is a really great, it also has other languages like R, but we're not going to be using R, so we're just going to focus on Python. And as I said, don't get overwhelmed, because we're going to start from the very beginning. So we're really just going to take our time with things. I always want to stress to students that don't feel that you got to learn everything and become extremely proficient at a programming language after one class. Okay, that's not going to happen. It's going to take years of practice, and even after graduating, you know, from school, you're going to have to practice even more, right? And it just depends on your interests. So certainly don't get scared by it, you know. just take it slow, and you'll learn to appreciate it eventually. All right, certainly in this program, we have a lot of programming courses in different languages, and so all of that is going to help you. All right, so here's this, so I provided this link, so what you will have to do, your homework assignment, is basically you scroll all the way down, and where you see Anaconda installers, you're gonna go ahead and, if you use Mac or Linux, you install that version. I assume most of you will be using Windows, so you will install, follow this installer. We will be using Python 3 and above. All right, so really whatever, for our purpose, usually when you're doing more complex things in Python, the version becomes more important. At this point, the version is not as important as long as it's above 3. And so that's perfectly fine. So as you can see, Anaconda, which as I said is somewhere between 3 gigs or 4 gigs, comes with a lot of libraries already pre-installed. We're really not going to use any of these really, except for the Jupyter Notebook. In the future, however, especially if you did the applied data science course, minor or other things, then you might use some of these other libraries. But I do think it's worth installing Anaconda. It just makes things a lot easier. It's also going to give all of us a common reference. You can download the 32-bit or the 64-bit depending on your operating system. So just check, what your operating system is, and download accordingly. Should be very straightforward. It's just a wizard. Get to the end. Once you have it installed, what's going to happen is you click on the little start button. Can you guys see my start button when I click on it? Or are you only seeing the website?
Only seeing the website. Okay,
yeah, so you can't see it. But anyway, if you click on the Windows start button, you'll have things, and some of them will say like Anaconda, and one will say Jupyter Notebook, for instance. So you would click on Jupyter Notebook. This is after installation, Jupyter Notebook, and then from there, you will be able to start working on programming. So for now, don't worry about that. I will discuss that on Wednesday. I really just want everyone to install the program right now. Let's see, so you guys keep writing on the chat. Let me see what I can. If you want to use other programs like PyCharm, or, I've used PyCharm, in Linux. So if you want to use that, that's perfectly fine too. Nothing that we're going to do in this semester requires Anaconda per se. I will be writing some of the examples in Jupyter Notebook, so just be aware of that. You will have to run them, figure out how to run them in your own environment, okay? But, so that's basically it. Are there any questions so far before we continue? So I've given you the link. You know where to go to download the program if you want to use this one. As you can see here, over 20 million users worldwide. So it's a widely used, widely supported framework. Questions? All right, everyone seems to be quiet. Okay, let's go back to the course website. Let me go back to Zoom here. I need to share. Okay, so now I'm going to share the Brightspace. Can you guys see Brightspace?
Yeah.
Yes, okay, great. All right, so here we are on Brightspace. As I said, you'll have we'll go over the syllabus in a second. So I posted the syllabus there. So I want to talk about the book, Zoom instructions. I want to make sure I covered everything. Resources, I provided, if you know, some references to Python. So this is actually like a condensed version of a lot of topics in Python. So if you're that type of learner that likes to just look at everything at once, this is not a book. This is only, you know, 10 pages or so, but it's a summarized. I sometimes want to call it a cheat sheet in a way. So you can take a look at that. It'll have examples of the different things you can do in Python. Look at that. And then as you can see after that, we just have the basic concepts of, you know, intro to programming, what is programming, variables, inputs and outputs, you know, very simple things. And you will see that actually Python, one thing I want to say, somebody mentioned C, C++. Well, I don't know if you know this, but all that Python is Python is an interface to C, C++. That's all it is. So that's why Python is so popular, because what happens is a lot of people develop libraries, you know, like the imports in C or C++, and those libraries in the background are C language-based programs, which means they are very efficient, right? So I don't know if you know this about programming languages, but some programming languages are faster than others. And one of the fastest programming languages, best programming languages actually, is C, C++. It's an amazing language that has been around, you know, since it was invented in the 50s and 60s at Bell Labs. And it's one that has endured, you know, and become just essential in technology in the world, and in anything related to software development. But Python is actually, you can think of it as just an interface above C, C++ that is meant to make programming a lot easier. But just keep in mind that whenever you're using those libraries in Python, they're actually in the background, you know, just C, C++ programs. And so, you know, they will be pretty good and efficient. Okay. All right. So that's a little bit of that. A few more things. One thing I want to mention, if I go to the announcements, you've probably seen this already. So here's the Zoom instructions. I've talked about the videos, Brightspace, office hours. You can see that there, Monday 12 to 2, or by email. The course website is there. I will post links there. And then the teaching assistant. All right. So this semester, the teaching assistant for ITS 140 for this section will be Mr. Mitch Burke. Okay. So he is going to help you. He's not going to grade, because I usually do the grading, you know, just to see how students are doing. But he can help you. So if you have any questions about software setup, you know, if you're, you know, something to do with the editor that you want to use, or something like that, or if you have questions about homework, you know, something that you don't understand, he is the teaching assistant that will be here to help us. Okay, so, you know, unfortunately, we're still online, so you can't just have like office hours, but instead you can email him about your questions, and you know, he will help this semester with that. All right, so that's basically everything on this. Your grade book will be here. So that's the other thing. All right, so now I think we're ready to take a look at the syllabus. So let's open up the syllabus. I need to share the syllabus. All right, so here is the, can you guys see the syllabus now?
Yes.
Yeah,
Okay,
I
great.
see it.
All right, great. So as you know, the course is called it's ITS 140.00. It's Introduction to Computer Algorithms and Logic, and it's just another name for programming, an intro to programming class. This is fall 2020, And so the office hours, as I said, Monday, 12 to 2. There's no prerequisites for this class. The book that we are using this semester is that one, starting out with Python, 4th edition. Okay, so I'm going to mute some of you. Or please mute your if you don't have a question, please mute your microphone so it's easier to go over this. Okay, so the textbook, as I said, this is a somewhat expensive book. I noticed it's the book that has been picked for this class, and it's a little bit expensive, but I guess you can get it if you'd like. It'll probably help you to follow along. What I like to do is I will do the slides. I'll have slides, and then I'll just, as I said, I will get into explaining some concepts. I'll use the Jupyter notebooks, as I said, maybe write some the problem, the pseudocode, and then the solution in Python. Or I will provide, various different ways of giving you the materials, okay? So in general, now as far as homework assignments, what I will probably do is just give you the problems separately instead of just saying, oh, do problems 7 and 8 from the book. So that way you would have the problems themselves. I can always just, what do you call it? Scan the problems and post them online. So you won't really have to have the book. I thought the book was too expensive, actually. So, oh yeah, somebody's got their hand up.
Yeah. So your syllabus says that it's the 4th edition book. I looked online on the P&W like bookstore,
Yes.
and I entered in the class, and it came up with the 5th edition. So I actually went and rented the 5th edition from Amazon.
That's fine.
I have
just the latest edition. I'm gonna correct the syllabus to just say the latest edition.
Okay.
I didn't.
Yeah, I was able to find. I just looked it up like for an e-text and found one like the 4th edition for like $25 or something.
Yeah, honestly, in my opinion, get the cheapest one that you can get. Okay, I mean, usually these books are not really that different. And as I said, I will provide all materials that are relevant. But for those of you that like reading books, get it. Okay. We won't do everything in the book. I'm going to stress certain parts, pseudocode. Certainly, I will stress that, and certain concepts. And then I will stress heavily Python. As I said, if I assign homework, what I will do is I will post the actual problem. Some of them may come from the book, some of them may come from other sources. But I will follow what I do want you to feel comfortable with is that I will follow the book's general ideas, okay? But some things I may modify a little bit. And as I said, that's why my source of giving you materials will be through the Jupyter Notebook, because Jupyter Notebooks imagine it's like a PowerPoint combined with programming somehow in a single way. And so that's kind of the approach that I will take. I feel it's more efficient in the end. But yeah, good. Get any edition. I will provide the problems. But it is an expensive book. It's almost $100. Are there any questions? Any other questions about this?
Yes, I have a question.
Yeah, go ahead, please.
So when we download Anaconda, do the Jupyter Notebook comes with Anaconda, or is that its own separate thing to download?
Yeah, no, that's the point of downloading Anaconda. It comes with everything.
All right.
So when you download it, everything will be there that we need in this semester, and possibly as you move on in your courses this program. And so today I'm not going to show, I'm not going to emphasize the Jupyter Notebook, but on Thursday, we will definitely get started with that. I'll get you guys set up with that. We'll just actually, we're not going to do any programming per se on Thursday. We're just going to get set up with the environment. But that's why what I want you to do between today and Thursday is install the program, look into it just so that you have it ready to go. Was there another question? I thought there was. Yes, that's a good way of putting it. The book is not required, but it would be a good thing to have. I don't usually require books in my courses. I like to provide all materials. However, I will try to be very consistent with that book. The order of the topics, the flow of the topics, the main ideas of the topics. I just like to provide my own materials, okay? I will probably use some of the slides of the book and so on, okay? And as I say, one of the important things, problems, usually books have really good problems in the back of the chapters for homework. What I will just do is just scan that part of the book and post the relevant problems, all right? But if you like to read books, go ahead, buy the book, maybe buy a slightly older edition, check, the 5th edition versus the 4th, 3rd edition, and make an assessment. All right, so let's go ahead and continue. So just, a few more details. So I think that summarizes the textbook. Let's go over the course description, very important. So this is ITS 140, Introduction to Computer Algorithms and Logic. We meet on Tuesdays and Thursdays at this time, 12 to 1:40. So this course covers introduction concepts of information technology programming, related programming, I should say. Topics include algorithm development. So we'll talk about algorithms, a sequence of commands and steps. Programming logic, obviously, as I said, this is an introduction to that. You'll certainly start writing code. Evaluating software programs, developing software through a variety of tools. As you will see, you can actually write a lot of things with a lot of tools. And analysis, development of software applications. So there will be a lot of laboratory assignments. Usually, once a week or once every 2 weeks, you will have a homework assignment. All right, so overview of programming languages. This is all based on the IEEE ACM curriculum for information technology. Overview of programming languages, contrast the differences between the structured and object-oriented programming paradigms. We're not gonna spend too much time on object-oriented programming, but because that's basically one of the last topics, but we will cover some of it. Now, there's this idea that sometimes whenever you're writing a program, you create a diagram. I will discuss that at some point, but rarely do programmers really use these diagrams. It's a good tool to have in the beginning, but it's not something that I'm going to emphasize too much. Other things, fundamentals of data structures. So Python is a programming language that's very simple for data structures. It doesn't have that many complex data structures, so we'll cover that. I will cover arrays basically from the pseudocode point of view, and then show you how this can be done in various ways in Python. So, data types, we'll talk about data types, and usually because Python is really an interface to C, obviously C has a lot of data types and it's a very complex set of data types that are available in something like C and C++. But in Python, this has been simplified. So there's really, you don't even have to define data types. in Python. And so we will look at that from the point of view of various programming languages, but also from the point of view of just Python and how simple it is in that language. We'll discuss some common applications of data structures as applications, basically. So, that just means I'm going to show you examples of different arrays and how we can use them. Then, of course, we'll cover the fundamental programming constructs of any program. As I said, all programs, whether it's C, C++, Python, Java, JavaScript, PHP, whatever the language, they all basically have some very basic building blocks. And these building blocks are available in all programming languages. So sometimes the only thing that changes is the syntax. The syntax is really like the language structure, how you write things, but the basic ideas are the same. So these are called the fundamental programming constructs. So basically, talk about, you can see that there, standard conditional structures, iterative control structures, and that's basically your if statements and your for loops. Okay, so we'll talk about that, if statements and for loops. Okay, sorry, that's not what I wanted to do. I'm looking for the pen here. I can't find it. No. All right, so that, yeah, so conditional and iterative structures, okay, which are the if statements and the for loops. We will talk about how to design, implement, test, and debug programs. So you'll spend a lot of your time doing that. So usually whenever you have a problem, you will, try to define the problem, maybe try to create some pseudocode, which is really just a sequence of steps that you want to follow. Then you're going to start thinking about what are these constructs that I have to use, right? And then using those constructs, you'll start to build your program. So in a way, it's like Legos, right? You're starting to build something from Lego blocks and you kind of have to put them in a sequence. And then once you've written something, once you've written something, then you're going to run it, right? But whenever you run any program, it crashes. And so that brings you to the idea of debugging a program. All right, so when you debug a program, debugging a program just means finding out all the errors, correcting them, and so on. Okay, and that's one of the things that if you're just writing pseudocode, you never know, right? You wrote pseudocode, you think it's right, but you don't quite know. Now, there are some programming languages where debugging is difficult because the syntax of the language itself is pretty complex. But here with a language like Python, you will see that the syntax is actually quite simple once you get past a few little things. And so we'll talk about that. So the fundamental programming constructs include, basic computation, calculations, math. I mean, at the end of the day, you have variables, you're doing multiplications, sums, etc. We'll talk about simple input and output, and that just translates into reading files, writing to files. So we'll and that's file management, but also initially just taking values into variables, right? So inputs and outputs. As I said, conditional and iterative structures. So that's for loops and if statements. And after that, getting into modules and defining modular programming, which means creating processes or procedures and functions. Okay. Okay. As I said, object-oriented programming, that's a it's an advanced concept in programming. So we'll get to that probably at the end of the semester, but we won't spend too much time on it. We'll discuss some of these concepts just for completion, but the emphasis of the class is really just to get you started with programming. You will definitely have a lot of courses throughout your years in school that will focus more on these ideas. And then basically the other, one of the key concepts or key objectives of this course is actually problem solving, okay? So you have to develop, if you're in this program, it's because you like complicated things, right? You like technology, you like computers, you like systems of computers, right? And you want to get them to work. You like automation, and a lot of that is usually problem solving. So we will discuss the importance of how algorithms are used in the problem solving process. Okay, so as you hear a lot about like AI and automation, and you hear how technology just keeps changing the world, and it's true, right? If you think maybe 30, 40 years ago or 30 years ago, there were a lot of people that did a lot of data processing. Engineers would just sit on drafting tables with calculators doing numbers, or people had to sort a lot of documents manually, and all of that has changed in this world of the digital era, and it keeps changing. So imagine the changes that are coming in the next 20 years during your lifetimes. And so it's important that understand that these algorithms are starting to become smarter and smarter and more powerful, and they can solve ever more complex problems. Okay, and so your goal, one of the goals of the class, is to get you started with this idea of problem solving. So we're going to talk about identifying the necessary properties of good algorithms. We're going to create algorithms for solving simple problems. So talk about that. The use of pseudocode or a programming language to implement, test, and debug algorithms for solving problems. So as I said, pseudocode is nothing more than a language independent, a programming language independent way of solving a problem. So, I give you the problem of, create a game, a very simple checkers game, right? And I just say that. So then you have to start thinking about the logic. So what you're going to do is you're going to maybe write it in words, write a list of the things you have to do. And then after that, start writing the pseudocode. And then after that, you start writing the actual code in C++ or Python for this course, and so on. Okay. And then basically strategies for debugging. So debugging is always extremely important. Strategies for debugging. Debugging, it's some people say that in the future, once you start working on programming quite a bit, 20% of it is just writing the code and 80% is the debugging. So a lot. So what I will say is this: before you start writing code, think about it for a little while, because if you don't, the problem is that you're going to write some code that's going to be very buggy, and then you're going to have to spend a lot of time figuring out what the problem was. Does that make sense, that idea, guys?
Yeah, totally. I can attest to 80% of your time is debugging.
Yeah.
It's more like 90, really.
Sure.
It's why does this not work, and trying to figure it out. And usually it's, oh, I mistyped something.
Yep, that's certainly true. And so that's just how it is. That's how it is. And so certainly thinking about something a little bit more will save you some time in that debugging, but and basically reusing your own code. And this is why it's good to have a GitHub account. So, you know, I would recommend that all of you, you're just getting started now, get your GitHub accounts. Any code that you write that you feel is something you're proud of, that you feel, okay, this is good code, put it on your own GitHub. And then what's going to happen is the next time around when you're doing something, you're going to be like, oh, I'm doing this, which is similar to what I did back then. I know that code works, so you can always reference your own code. And that's something that I do all the time. Whenever I have a question, I'm doing something, oh, okay, I remember this, and I can always look up something really quickly. It's going to be there on the web. You know, again, if you write your Jupyter notebooks along the course, you can also load up your Jupyter notebooks on there. And so that way you have kind of your own little book of your own notes with your own explanations, images, and everything, links. And so it'll just, you know, it's a good repository of your information. You can always check Google, obviously, for other person's code. But if you've done something, reuse it in the future, and it'll just make you more efficient. All right. Excellent. So those are some of the topics that we will cover. The next thing, I've already talked about this, so the requirements. So I said either, you know, Anaconda is just, you know, one single download, basically, if you want to call it that. Some people said they like PyCharm or other approaches. You know, go ahead and get your own Python interpreter. That's perfectly fine. You know, you can do things however you want. At the end of the day, I'm just going to want you to show me evidence of the program that you wrote and the solution to the problem. Okay. So let's see. The grading criteria, I'm sure you have questions about that. Basically, it's out of 100%. So we have a lot of assignments and homework assignments in this class. So that's going to be 40% of your grade is going to be labs. We will have about 10% of your grade allocated to quizzes and participation. So quizzes, you know, are going to be pop quizzes of some kind. Maybe on Brightspace during a class period, I might open for 20, 30 minutes Brightspace, and you just have to, you know, I may just ask you, you know, write a Jupyter notebook to solve, or I might give you a problem with a Jupyter notebook, you download it, and then you provide the solution and something like that. All right, so that's the participation would be if, you know, just regular attendance, you know, basically that when I'm reviewing this, I remember who you are. That's really, it helps me to get to know everyone in the class and, you know, make sure you're participating. All right, and then we have exams. So as you can see, exams here, that's 30% of your grade. We're gonna have 3 exams. 1 exam is gonna happen at week, and I'll go back to the calendar to show you those little details. 1 exam is at week 6, 1 exam is at week 12, and the third exam is the final exam. All right, so you'll have 3 exams. You know, usually these would have been written exams if we were in the classroom. Given this whole scenario, you know, I'm sure all your professors have different approaches. So we'll see. This being a programming class, we'll figure it out. Again, probably a Jupyter notebook of some kind. And that would probably be, that way you can always write answers, run a little bit of code, get a little bit of feedback in the debugging. All right, and then finally, there's going to be a project worth 20% of your grade, and that's something that's going to be due at the end of the semester. It'll be either a group project or an individual project. I haven't decided yet. But obviously, as you might imagine, it's something that brings together all the topics that we have discussed in the class. So all the topics, and then to implement some kind of a solution to a problem. Okay. All right, you can see the grading scale there, pretty standard, you know, A through F. Okay, and then after that, go ahead and read all these instructions. Some of this might change, you know, we'll adapt. But take a look at it. Certainly one thing I want to stress is I do not accept late homework. And I do not accept homework sent to me via email. The only way, because otherwise I would get hundreds of emails that I'm not going to be able to get to. Okay, so no homework should be submitted via email. Please submit your homework on Blackboard. Also, that allows me to enforce the fact that you should only be submitting homework on time, right? So usually the way homework works is I'll assign a homework assignment on Thursday and you have 1 week to submit it. So the homework would be due the following Thursday by like 10 p.m. Okay? That way it gives you a time to meet with me that Thursday if you have questions before you actually have to submit your homework. All right? So that will be the plan for that. And so that those are 2 strict rules. No homework sent via email. All of it has to be submitted via Brightspace, you know, this course management system, and the homework should not be submitted late. If you miss the deadline, the system will close and you will not be able to submit your homework. Okay, so definitely start your homework early and on, you know, so that you're not struggling at the very end. Okay. Then you have all the PNW policies, so make sure you read through all of those. Okay. Then emergencies, obviously we're not on campus, but you know, when you're back on campus, you know, there's all the emergency guides. So, you know, be aware of those phone numbers so you can always access them at any time. Okay. And then finally, I have a little course schedule here, an outline of the topics. As you can see, this is subject to change, right? Now I'll modify it, but usually it follows the logic of any introductory programming class. The book, you know, as I said, I forget, Gaddis, sorry, Gaddis, the author Gaddis book. Okay, so I will follow that. And it's basically, you know, it's an introduction. What is a computer? You know, how do computers work? So that's really chapter 1. And then input, processing, and output, as I said, just really like thinking of variables. You know, how do you take a variable into your program? How do you write out, you know, print statements basically in Python, and the input. So Python has, you know, what is called the input function, and then it's got the print statement. And so that's really what that means. But, you know, in a more general way, I'll cover it through the Gaddis discussion. You know, because I do believe there's value in not just always jumping into Python right away. So we'll probably spend some time writing the pseudocode, you know, in the notebook. The pseudocode will just be like text, regular text, and then, you know, the actual Python code will be in the area that's in the interpreter, and that way we can see what's going on. All right, so after input, processing, and outputs, you can see that's just the first 2 weeks. So the first 2 weeks are kind of the slowest, if you will. And then after that, we get into modules, modular programming, that gets a little bit more interesting. And then we get into the absolute workhorses of programming, which are decision structure. These are the so-called if statements, if you've ever heard of them. Boolean logic, right? So, you know, Boolean tables, you know, we'll talk a little bit about that. And then there's repetition structure. So as you know, computers are very efficient at performing individual tasks, you know, fast, right? So, you know, if you want to calculate numbers or do it, you know, a Fibonacci sequence, you know, I like to do that. You know, I like so for instance, one of the problems I like to give you is, I'm sure you've heard of Fibonacci in your math class, in high school, possibly. So I'll just say, okay, write the code for a Fibonacci sequence, right? Or something like that. And so, you know, you'll figure out, okay, do I need decision structures, repetition structures, and so on. We got the functions over here. So that, you know, functions are essential, things that take in an input, return a value. You know, functions are very important when you're writing modular code because it makes the code more readable, more efficient. As you can see here in the schedule, somewhere around week 6, week 7, we're going to have exam 1. Okay, just take a look, make a note of that. Then after that, we're going to have more, excuse me, more on decisions and repetitions. More on decisions and repetitions. And it's the same, more for loops. So there's various ways of doing for loops. There's something called so Python is widely used, and there's something called the Python-y way of doing things. And that just means that, you know, we can do certain things a little bit more efficiently. And so that's, you know, that this is more advanced concepts. So that usually here I'll cover the list comprehension. And so I'll show you what that is. So around, oh, this should say full break. Sorry, so I'll correct that. After that, we have input validation. Can anyone tell me, what do you think input validation is? What is input what if you see that term, what do you think that is?
You're putting in so you can go ahead.
Just like make sure it works, like what you put in actually works.
So that would be, I would say that actually works is a little bit more like debugging. It's a little bit of it, but it's more like debugging. Anyone else? What is input validation? Another.
Input validation is you're putting in a set of parameters that when the user is using the program, you're making sure that what the values or whatever they're putting in is exactly what you want them to be put in. So like,
yes.
If it's numbers, you have to make sure that they're putting in integers. If you want them to actually type stuff out, you want to make sure that's a string or whatever the equivalent in Python is.
Exactly. And that actually brings the idea of what is called software assurance. So software assurance is, you actually have I don't know if you guys know this, you actually have a course, ITS 450, called software assurance. And it's a whole semester of just input validation. You're surprised, but that's how important input validation is. You have an entire course on it. And what software assurance means is that it is both providing assurance of software for both security, but also for quality. So I think everything you said, what's your name, by the way? I'm sorry.
Emily. My name is Emily.
Emily, yeah. So Emily, everything Emily said was for quality, right? So a lot of it was mostly for quality, but there's also for security. So the fact that, you know, you have to prevent certain inputs, because sometimes when somebody enters an input into a text box, that input will go to a database. And if they know what they're doing, like they're a hacker, you know, you've heard of hackers, I'm sure. Hackers, what they're always looking for is they're looking for bugs in the code that they can exploit to take over the program. All right, and you will see then that input validation is very important. So you'll see later on, you'll certainly input validation is a topic that you're going to cover a lot throughout the next few years. And it's important. Okay. And so the course I will discuss it as well as it relates to software assurance, both for quality and security. But Emily's definition of it was excellent. You know, just making sure that if an input is supposed to be, for instance, temperature in Fahrenheit, right? Then there are certain ranges for those values. And so you want to keep your inputs, you want to keep your inputs constrained like that. All right. Then after that, we're going to discuss, as you can see here, arrays. And arrays are really, you know, whereas you have one variable that holds one value, an array is basically a set of values that you have within an individual structure. And so we will talk about that. There's a lot of data structures and other programming languages. In Python, you know, pretty much everything is called a list. Or sometimes there's a library called NumPy where things are called NumPy arrays. However, we will not in this course cover NumPy arrays. Instead, we will just limit our discussion to the Python list and the Python dictionary. All right, and those really fall within the idea of an array. Okay, so we will talk about that. Here with arrays, I do have to kind of first start with the view of arrays from the point of view of pseudocode, and then after that get into the specifics of the application of arrays in the Python language. Okay, does that make sense, guys?
Yep.
Any questions so far?
I just have to ask a quick question
Yes, please.
for my own benefit.
Yes.
So I know we're going to be covering it
Yes.
with the arrays, but so Python does not have like 2D arrays.
It does have 2D arrays. It does. Just it's a list of lists.
Okay.
If that makes sense. It's just it does have it. It's going to be, you know, how you know it, index I, index J. But the way that it's crafted is that really everything is called a list. You know.
Okay.
That's really all it is. But it does have arrays of many dimensions. Yes.
All right.
I have a question about
Yeah.
arrays and debugging. So debugging is
Yes.
to see if there are any problems in the program and
Yes.
then fixing it. While
Yes.
input is to make sure it had the parameters the inputs need for it to work.
That's right. That's right. So that's a good way of putting it. So debugging is anything, right? So someone had mentioned before, you were supposed to have a semicolon in the code and you forgot to put it there, right? So that's what debugging is. It's just making sure the code doesn't have any errors. Whereas input validation has to do with inputs and outputs, right? So it's once your program is running, people are going to type in. So it's more of a execution mode kind of thing. So somebody is running the program. They needed to enter the temperature in Fahrenheit, but they entered the letter A. That's wrong, correct? Do you see what I'm saying?
Yeah, I got it.
Yeah. And so that would be input validation, where basically what you want to do is you were expecting temperature in Fahrenheit, they entered the letter A, so now you don't want the program to error out. Instead, what you want is for the program to acknowledge that that was an error and give a message, an error message saying, hey, that's not the valid input. Please enter a temperature within this range, for instance. And you can do that easily with any programming language. Good, great questions. Any other questions?
Yes, I have a question, but it's not coding related. I'm just looking at the schedule for like the final couple weeks. Are we gonna have a final, or is exam 2 going to be our final?
We have a final exam during finals week. We have 3 exams. Each, I think, is worth 10% of your grade. So we have one exam, exam 1 on week 6, around week 6. It just depends on where you guys are, right? So sometimes a class can be very fast or sometimes a little bit slower. So but it'll be around week 6. Second exam will be sometime around week 12 and then, or 13. And then there will be definitely an exam, a final exam during finals week.
Thank you.
Good question, yes. All exams in this course are comprehensive, okay? So what that means is that they will include everything, anything that we've covered during the semester up until that point. So, you know, obviously, so when you get to the final exam during finals week, that could include things from week 1, you know, or any week, because they are comprehensive. Usually they would be written exams, but here they're not multiple choice, by the way. They're usually just like problems that you have to solve, but we'll see how we adapt it given that we're online right now. Great questions. Any other questions? All right. So we talked about arrays, right? And that's a very important idea. And Python, as I said, Python really, arrays are called lists. But if you use the NumPy library, then arrays are called NumPy arrays. And so I might at the very end just kind of introduce that very lightly because it's really very intuitive. But I will initially just focus on lists. After that, we'll cover files, and that just means, you know, what if you have data in your program that you want to save? You know, maybe you want to have, you have a list of numbers, right? You were running your program and you want to turn off your computer, but you also want to save that information. So you need to save it to disk, right? And so what that's usually, the way that you do that is that you save it to a file. Okay, and so we're going to talk about reading and writing from files and some of the, you know, basically the principles of that, the pseudocode, and then we're going to get into, you know, how Python does it and so on. Okay, so we'll see that. There's a lot of things that can be done there. So, you know, do we want to save a file as a text file versus do we want to save it more of as a binary representation? So we can look at a lot of that. Are there any questions on files? All right, and then that's pretty much all the main topics. The very last one is menu-driven programs. So usually Python programs are very just sequential kind of console type programs. However, we can create menus, all right? And for this, as you know, as it'll become obvious to you, usually will require some kind of a library. So we'll bring a library and now we'll be able to create like a little screen, a little menu kind of thing. And then we'll have buttons and we press this button and something happens. We press, you know, it's going to be more event driven. So when it says here, menu driven programs, what that means is basically that it's, instead of being sequential, a console type of a program, it is now more of an event-driven, like a website kind of a program. So we'll talk about that as well. And usually then at this point, given how this class is, the very last 2 weeks of the semester before the final exam are just left for the project. So really there, what you guys will do is you'll work on your term project. You can meet with me if you have questions. I can help you. The project is not very complex. It's just meant to be something that brings in all of these topics. So all of these topics that we've covered, right? It's going to bring all of them together so that you can implement some kind of an application. So at some point in the semester, somewhere around probably right after exam 1, a couple of weeks after exam 1, I will ask you about ideas that you might have for creating a project. So this could be like a game or it could be like a menu-driven application. It could be a lot of things. So we'll talk about it later on. All right. So that concludes the schedule. So that's the schedule. Okay, and so those are the details. So let me go back to the calendar. I want to go back to the calendar here. Let me share. So before I move to the calendar, I'm done with the syllabus. Are there any questions about the syllabus? Is there anything in the syllabus is very important. Remember that, you know, you have to follow a lot of these instructions, you know, like in particular, usually the thing that students have problems with is homework submission, you know, so remember the rules, not submitting homework late, and homework has to be submitted on Brightspace, not via email. But otherwise, are there any questions about the syllabus? All right, seems like that's clear. Sounds good. All right, let's go back to the calendar just for a sec. I want to point out something. I need to share that. All right, so you guys are seeing the website, hopefully. Here's the calendar, okay? You can see the calendar. Can you guys see calendar fall 2020?
Yes.
Yes, all right, great. So this is for this semester. As you can see, it's currently blank. Every week, basically, I will be updating it. So for instance, today's class, today's video, right? I will provide a link that will be here for the video, all right, and so on. And then I will provide, you know, I'll write things like what we did that day, so the intro to the course and so on. Important dates to note, because I know you guys have some questions. September 7th is a holiday, so that doesn't affect us. Then we have fall break week, October the 12th to the 13th. So obviously this day, no class. Thanksgiving break is going to be on the 26th, so that's going to affect that class. Then finals will be this week, so the December 14th through the 18th. I don't know the date of the final exam yet, but I will confirm that with you guys as we get closer to it. Now, I talked about the term project, right? I talked about the term project, and I want to stress that the project, what you have to do is you have to find a problem, you have to solve it, and you have to implement it in Python. What you will have to do is you have to do what we call here in our program demos. Everything you do in a class, you always have to demo it. And what that means is you're not just going to talk about this is what we were going to do and, you know, this is how we would have done it. Instead, you have to say this is what we did and here it is. And you always have to run your own code. Okay, so that's pretty important. So usually what I do is I do presentations on the last week. So I saved the days of December the 8th and December the 10th for project presentations and demos. So I give 2 days because sometimes a student, you know, their projects for some reason doesn't work. So that gives them a second chance to present on December 7th. Remember, that's very important. It's worth 20% of your grade. Okay, all right, and that's the last thing. So that's basically everything that I wanted to say administrative about the course. Okay, are there any questions? So that should cover everything admin related. Is everything clear?
Yeah.
Okay, great. So you know how to get on Zoom, you know where to find materials. You'll see where to submit assignments. We'll talk about how you're going to submit your assignments. You know, whenever you have a lot of files in your assignment, you're going to have to compress things using zip. Please only use zip for compression because my computer only has that. And what's going to happen is if I can't open it, I won't be able to grade it. Okay, so make sure you follow all of those guidelines. All right, so let me switch now to Brightspace. Okay, I think I'm there. You can see the Brightspace, correct?
Yes.
All right, excellent. So we're almost out of time. We have 2 minutes left. So I'm just going to save these slides. So the very first lecture that we're going to do is the one called Intro to Programming. So that's chapter 1 here, or CH1. You can see that. I will probably add another set of slides here. And I will start that discussion on Thursday. So on Thursday, I will go over these slides. That will be the goal. And then the second goal will be for me to do a demo of Anaconda, right? And in particular, like the Jupyter Notebook, I'm going to show you guys how the basic writing code, saving the file, reloading your file, writing text on it, maybe putting a nice picture or something like that. Okay, and so it's very important. What I would recommend is that for the class on Thursday, make sure you've installed Anaconda if you're going to use this. If you want to use the Jupyter Notebooks, have it. Or if I think someone said they have like PyCharm or they like other approaches, that's perfectly fine too. But please just have it ready to go so that maybe as I'm doing things, you can try to follow along. And then if you get stuck with something, you can ask questions. Also remember, the teaching assistant is Mr. Mitch Burke, and he can help you with questions on software setup or writing your code. Okay? All right, so, I love Python. It's an excellent platform. So you'll certainly, it's a tool that is going to make you, give you a lot of power. And I guarantee you're going to be using it for a very long time. As I said, it uses C, C++ in the background. So, and that's the gold standard. So it's definitely something worthwhile. And also just the fact that you're learning programming, that's also very, very important. So I think you're going to really enjoy the class. I'm looking forward to teaching it. And we're going to have fun this semester. Okay? So with this, I'm going to conclude today's lecture. As I said, on Thursday, I'll start with the slides and then just demo of some of the software, and that's it. All right, so I will see you guys on Thursday. Oh, hold on. Before you leave, don't leave. I need to take a picture of who is...
I was close.
Yes. I need to, because I told you, because of the course, what do you call it? Participation. I need to get, it's like a roll call. So just give me a second. I'm going to stop sharing. Okay, and I'm just going to really quickly just take a picture of everyone that's here. Make sure that you come to class because I need to make sure that I know who's here. It's a requirement of the university. All right, I think I have everyone. Okay, great, excellent. So nice meeting you all, and I'll see you on Thursday.
Sure.
Bye-bye.